Hello there. I wanted to make a video today about the N47 timing chain, which if you're watching this video you obviously know is quite notorious for premature wear and snapping even, and this is causing people a lot of problems in terms of having the chain replaced, which is quite costly, or even blowing the engine up because of a snap chain, which is even more costly as it requires basically a brand new engine. The N47 engine was fitted to BMW 4-cylinder diesels from about 2000 and I think it was late 2006 till possibly 2010 or even later, I think 2012. I'm not sure when exactly they switched over to the B47. But the majority of failures were from the earlier sort of 2007, 2008 models, and but obviously failure and other problems were experienced by people even with the later engines. So this has been, although the N47 engine itself is relatively good, it has kind of a very weak Achilles heel, which I'm hoping to demonstrate today. So a little bit on my background. I'm not a mechanic. I don't fix cars for a living. I don't actually have any qualifications in automotive science, but I do have 2 masters in science and engineering, and I'm working towards a PhD. And my group, which is the mechanical engineering group, specifically tribology, they study the wear of parts, so contacting surfaces and how they wear and the mechanisms thereof. And even though my work itself isn't to do with tribology, I've learned a lot from my colleagues and obviously attending talks and lectures and stuff, so hopefully I can shed some of what I've learned with you. Now, so my story is I had the timing chain replaced on my car because there was a sort of swishing or brushing sound, sort of like as if you were sweeping the floor with one of those old straw brooms, like and there was a regular cadence to this. So the sound was only really appearing when the engine was warm, and you had to rev the engine between 1,500 and 2,500 revs to actually hear the sound. I'll explain a little bit later why I think that was. So, going onto the internet and all the forums and seeing blown up engine bits and all of that, I decided to take the plunge and have it changed because I intend to keep the car for a long time. Besides, the car is 100,000 miles, which I think is a reasonable life expectancy for pretty much a moving, rubbing part. I know the engines are meant to, the timing chains are meant to be fitted for life, but that's obviously not the case, is it? So let's go and have a look at what the timing chain actually does, how it sits in the engine, and then we can take a closer look at the components themselves. So when I had the timing chain replaced, I asked the mechanic to just keep the chain for me because I'm very curious and I'd like to see what was actually going wrong with it. So let's have a look. So as you can see there, this is how the timing chain will sit on the back of the engine. So if you can imagine, into the table would be going towards the front of the engine. So the chain starts, the motion starts over here. So here's where you would have your crankshaft sprocket. So that's basically the pistons of your engine drive the crankshaft, which is sitting over here. So as the crankshaft sprocket turns, it turns the chain, and the chain goes over here to a high pressure fuel pump sprocket. There's a secondary chain, so this is the primary chain. There's a secondary chain here, which is a thinner chain, obviously, because it needs to drive less torque. And this chain drives from the high pressure fuel pump sprocket to the camshaft sprocket. So the camshaft is basically what, so it's a bar with cams on it, and it gives the timing of the valves to open and close. So as the engine is turning, it's driving the fuel pump, and the fuel pump sprocket is then connected to the camshaft sprocket. And all of these need to work in a very tightly controlled sequence. Otherwise you will get misfires, or you will have valve and piston connection, which is obviously damages the valves, possibly the piston, and possibly other components as well. So these things need to be very precisely timed, and for this reason the chains themselves need to be kept tight, because over time, as they wear and stretch, they need to be pressed to take the slack out of the chain. So how it works is you have these nylon guides, which are these brown bananas, and these are basically, these two over here, these are fixed, they do not move, so they are simply providing some tension, and are the guides for the chain, so they don't flap around in this axis, in the vertical axis. Then you have your the other two guides here, and your tensioners, which apply a force onto the guides to take the slack out of the chain. Now, the tensioners themselves, they're actually driven by two things. One of them is they're spring driven. So here you can see the spring of one of them. So if you push this in, it's driven by the spring, but it's also driven by the oil pressure, which is Y at the back here. So this will be the part connected to the engine through this bolt here. And you will have oil fed through this channel here into this orifice here. And the oil, because of the pressure, it will cause the piston to move out. So you have one, the spring mainly acts, I think, at lower revs, because you need less force to maintain tension in the chain. Then as the revs climb up, you get more oil pressure, and the oil pressure drives the piston out into the guide to maintain the tension. So that's the bottom tensioner. Same with the top tensioner. You can see here it's spring driven, but also there's holes through which the oil, so this thing is actually screwed into the engine, and the oil pressure is driven through these tiny holes over here, and that also helps to drive at higher revs the tensioner into the nylon guides. So let's take a closer look at these. Find a stable surface to put the camera on. There we go. Right, so let's have a look at these components. So the first component is the camshaft sprocket. So So from what I know from metallurgy, I think typically the automotive companies, when they manufacture parts like this, they will typically have a hard metal coating. So obviously one that resists wear on, so that the sprocket doesn't wear itself. Obviously I haven't done any metallurgical analysis or any kind of X-ray diffraction or anything to find out what the metal or hard metal is, but this is just an assumption I can make. So when I look at the sprocket itself, I can tell that, you know, it actually looks pretty good. It doesn't appear to be any signs of wear on the sprocket itself, so that's good. Alright. Okay, so the sprocket is fine. The next part we move on to is the nylon guides. So these guides, as you can see here, there is somewhere you can actually see the track marks, which are these sort of like darker bits on the outer edges on the inside here. So it does appear that the guides have worn themselves. So these are made of nylon. It's basically plastic. These have worn, but when you sort of look at it from this perspective, it doesn't look like they've worn all that much. So I think these are fine. There may be some slight wear in them, but generally they seem okay. Here's another one. You can see, once again, you can see the track marks, but the recess itself from the wear is not, it's maybe a micron or two. It's difficult to say, but it doesn't look very much worn. Next, let's look at the chains themselves. So this is where people think is the main problem, which obviously is when it starts. So this is the secondary chain, the longer chain. So this chain is thinner than the primary chain simply because it only has to drive the camshaft. So when you look at the chain, you can see polishing, which is typical of wear. And that polishing should be even along these vertical pins, right? So for the most part, it looks pretty even. However, on some of these, you can see that. Let me find a good example. Some of these, you can see, for example, this one here. I don't know if you can see it on the camera, but let's get a focus. So you can see that the top part of this pin here between my thumbs is rather well polished, whereas the bottom is still pretty rough. So this indicates to me that as the chain is going around, there's some up and or so if the chain was like this, so parallel to the ground, there would be some vertical movement in the chain. So as the chain stretches, depends on where it's currently stretching, it will develop a sort of a slap as it approaches the stretched part. And my hypothesis is that some of these that are unevenly worn, that's where the chain has had deflection in the wrong, not the direction of travel of the chain, but in the perpendicular axis to that. And there are quite a few of these pins that have this wear. It's not just the one that I found there. There are others, for example, here as well. This is a pretty bad one. Okay, so the thing is with timing chains is you do expect wear. But as the chain is wearing, you expect tension to be maintained in the chain. So let's look at the crankshaft chain, or the primary chain. Once again, you can see the same sort of wear pattern in the center. It's pretty nicely polished and it's even. However, once again, some of these you can see that there is some, for example here, you can see that there is some uneven wear. So if I hold that to the light, can I get a focus on that? So you can see that the bottom part is pretty polished, but so between my thumbs again, compared to the top part of the pin. So as I was saying, you do expect wear and stretch on the chain, which is why you have the tensioners. So the tensioners will, as the chain slackens over time, your tensioner goes from being compressed and it will eventually elongate to go and push out into the chain and take the tension out. Now the tensioner themselves, you can see here, are actually pretty badly worn. So here you can see, I mean, look at the marks on this one. So you can see there's a lot of these vertical lines which are probably consistent with the part sticking and the vibration causing it to scratch as it sort of rotates around. So that will cause these vertical stripes. And I think what happened with mine is, so the spring itself is still okay, there's a decent amount of force on the spring, but the oil pressure driven part, I suspect, is where the problem was. So if there's oil pressure coming in through the orifice and pushing the piston out, and the thing gets stuck because of this texture on the piston itself, and it's obviously not pushing into the chain, and the chain is slack. Another thing to notice is these scratch marks go all the way down to the end of the travel of the tension itself. So that means this thing has probably gone to full extension before, and all the swishing noises and stuff were a result of this thing not being able to push any further into the chain. So the same thing with the bottom tensioner. So you have your spring. The springs maintains pretty good tension there. But once again, so the one side of the tension, the bottom tensioner piston, you can see is pretty smooth. But look at the other side. So I think some of this corrosion resulted from me washing this thing. So I washed it with detergent. But obviously, when it comes to corrosion, parts corrode a lot faster when they have been stressed, when they have been they have plastic deformation or some kind of subsurface damage and stuff. So you can see here that this is pretty badly corroded on the one side. So this is once again consistent with the tensioner sticking. Now what causes this? So I think for the case of my car, this is actually the problem and was the result of the sound. So what causes this these sort of marks on the tensioner? Why is it wearing out? Well, it turns out, I think the chains themselves could probably last, 200,000 miles, but the tensioners, I don't see them going well beyond 100,000 miles, especially with the BMW, the onboard calculations of the service interval. So my car has a full service history, but the intervals were at around 18,000 miles, which I think is way too long. I don't care how good the oil is that you're using in the car. There's no oil that can keep its lubrication properties for 18,000 miles. So simply, I mean, there's a couple of reasons for this. First is you get water buildup in the oil. You get oxidation, because obviously high temperatures and hydrocarbons, you get some oxidation. And also, I think one of the main mechanisms by which the lubrication properties of the chain go down is during DPF regenerations, which in essence do dilute the engine oil with diesel, and obviously that will degrade its properties over time as well. So all of these things combine to decrease the lubrication efficiency of the oil, and that results in metal-to-metal contact here in the tensioner, which then results in this wear and, in my opinion, sticking of this tensioner. It's not as smooth the travel into the tensioner as it should be. So there it is, guys. That's the breakdown of the N47. Now I know, so I had this done pretty cheaply. It's £450 done in Coventry. I can give the details if anyone's interested. And that was all inclusive, so that's the chain, the fitting, and the oil service, obviously, that you need after replacing the chain. And I think I've seen quotes for £1,000 to £2,000 to get the chain fixed, which I think is ridiculous. You really should go and find somebody who can do it a bit cheaper. It is a one-day job, and I think for £450, if you intend to keep the car, you should do it, especially from what I've seen on the components themselves as they've come out. Now I know the earlier models, so the N47 D20A models, as far as I know, these ones, the issue with them was a excessively sharp, I think it was the crankshaft sprocket. So, I mean, this is the camshaft sprocket. The camshaft sprocket would be the one at the bottom. I've seen reports of it being excessively sharp, and that wears into the chain and eventually results in wearing prematurely. But as far as I know, for the N47 D20C engines, so these ones were from, I believe it was March 2009 onwards. These ones, they improved the design of that sprocket, so they obviously reduced the aggressive profile. I don't know what they did, but they made them less aggressive onto the chain. These ones, although they don't fail through simply the wear of the sprockets onto the chain, they do suffer from tensioner wear, which is what happened with my car. So yeah, once again, guys, I urge you to get it done. 100,000 miles, I think, it's reasonable to expect a tensioner to wear down. I know they say that the timing chain is for life. It's located at the back of the engine because of that. But as far as I know, although the chain may be lifetime, the tensioners certainly are not. And I would get them replaced if you want to keep your car and not make it go bang. Thanks for watching, and let me know of any comments or suggestions you have in the comments below. Cheers.